An investor deposits 50,000 into savings account, which earns annual effective discount rate of 3.2%. Investor then draws an amount X at the end of every 2-year period. And the balance at the end of 12 years, just after the withdrawal, is 45,000. And determine which of the following is an equation of value that can be used to solve for X. So since the ending balance is 45,000, all these choices seem to suggest that that balance has been brought to time zero, because here you're dividing by an interest factor, and here you're multiplying by a discount factor. And both of these result in bringing the value from future to present, or bringing it backwards. So therefore, most probably the values have been evaluated at time zero. And this can also be determined from this 50,000, because this was deposited today. And so 50,000 is being left untouched. So that indicates that both the left sides and right sides are values at time zero. So now here we are given a discount rate, and we know from equation 8.5 that the present value, or the principal under the discount rate, is obtained by multiplying the amount function by 1 minus d power t. So the present value of the 12-year balance of 45,000, remember we are told that at the end the balance is 45,000 at the end of 12 years. So the present value of this balance, let's call it P1, be 45,000 times 1 minus the discount rate, which was 3.2% given in the problem, power 12. And so 45,000 times 0.968 power 12. So we don't need to evaluate it, because in this case, we are leaving a lot of things in forms like this. If you look at the answer choices, so the answer choices, there is this choice of 45,000 times 0.968 to the 12. So at this point, we can be pretty sure that it's either going to be choice C or choice E. Now, withdrawals of X happen every 2 years, as we are told. So withdraws an amount X at the end of every 2-year period. And over 12 years, if withdrawals happen every 2 years, at the end of every 2 years, then that means they're happening at times 2, 4, 6, 8, 10, and 12. So the present value of these withdrawals can be found by brute force. Let's call it P2. So the first X, so again, we will be using 8.5 to bring it from a future to a previous time. In this case, we are bringing them to present. So the withdrawal that happens at time 2 is brought back through 2 periods with this equation. And the withdrawal amount was X, and it will be multiplied by 1 minus d to the t, so 1 minus 0.032 square. Similarly, the withdrawal that happened at time 4, its value at time 0 would be x times 1 minus 0.032 to the 4, and so on up to x times 1 minus 0.032 to the 12. And 1 minus 0.032 is 0.968. So if we factor out an x from these terms, we get x times 0.968 square plus 0.9684 plus 0.9686 up to 0.968 to the 12, which in summation rotation can be written as summation of 0.968 power 2k, k goes from 1 to 6. Now, the sum of these two present values, one for the balance of 45,000 and the other for the withdrawals, should be equal to the initial deposit of 50,000, because it's that initial deposit of 50,000 which eventually creates the balance of 45,000 after the withdrawal. So the two present values should equal the initial present value, 50,000. So P1 plus P2 is 50,000. And now we substitute the values of P1 and P2. P1 was 45,000 times 0.968 to the 12, and P2 was X times 0.968 to the 2K. This summation equals 50,000, and that was choice C.